Hello, this is Mrs. Thompson again, and we are continuing with applications of radian measures. The objectives that we will be covering are computing the arc length of a sector of a circle and understanding linear velocity and angular velocity. Arc length of a sector or portion of a circle. If theta is a central angle in radians on a circle of radius r, then the length of the intercept arc S is given by S equals r times theta. So, in the diagram, you see a central angle, that is theta. Most importantly, you see the arc. It is color-coded in blue. To find the length of the arc, which is represented by the letter S, you would multiply the radius of the circle times the central angle. It is very important that you remember when using this formula, your central angle is required to be in radians. Therefore, if your central angle is given to you in degrees, you must apply what was covered in the previous lesson to convert the angle measurement from degrees to radian before substituting that measure into the arc length formula. An example: find the length of the arc intercept by a central angle of theta equals pi over 3 in a circle of radius 24 centimeters. Our formula for finding the length of an arc is S equals r times theta. We were given r, the radius of 24 centimeters. We are lucky this time. Our angle is given to us in radian. We know that because whenever our angle measurement contains the pi symbol, it is in radian, whether we see the word radian or abbreviation for radian typed behind the angle measurement or not. So that radian measure pi over 3, multiplying the 3 straight across, 24 times pi, 24 pi. Understood 1 times 3 gives us 3. 24 divided by 3 will give us 8 pi for an exact answer. However, this time we have an approximate answer, round to 2 places behind the decimal. This was obtained by plugging in 3.14 for pi. So 24 times 3.14, taking that answer and dividing it by 3 gives the final approximated answer of 25 and 1300 centimeter. This final answer has a minute amount of approximation in it because a rounded value was substituted in the formula, that rounded value being 3.14 for pi. Looking at an additional application of finding the length of an arc intercept by a central angle in a circle of radius r. This is a more typical example because, as you can see, the angle measurement is given in degrees. We are more accustomed to giving and receiving angle measurements in degrees. But remember, our formula for finding the length of an arc requires that the angle measurement is plugged in radians, not in degrees. Vance Grammar Community College in Vance County is on the 36th parallel. This means that an arc from Vance Grammar Community College to the North Pole subtends a central angle of 36 degrees. So, in other words, our central angle right here has a measure of 36 degrees. We can see 1, side of the angle stopping at the North Pole, the other one down here in North America at VGCC. The Earth radius is 3,950 miles. How far is Vance Grammar Community College from Santa's home? In other words, how far is Vance Grammar Community College from the North Pole? Well, as you can see from the picture, to travel from Vance Grammar Community College to the North Pole, taking a direct route, that trip would require traveling along an arc. So the distance from Vance Grammar Community College to the North Pole is an arc length. So all we have to do is find the length of the arc. As a reminder, the length of an arc, S, is equal to R times theta. Plugging in this formula for R, we already know our radius. It was given to us, 3,950 miles. But that radius must be multiplied by the angle in radian. Therefore, 36 degrees must be converted to radian. After doing so, we find that 36 degrees is equal to pi over 5, or you could read it as 1/5 pi in radian. As a reminder from yesterday's lesson, to convert 36 degrees to radian, you would multiply 36 degrees times pi over 180 degrees. The degrees would cross cancel out that unit, leaving us with multiplying 36 times pi to get 36 pi, understood denominator 1 times 180 to get 180, and 36 over 180 will reduce or simplify to 1/5 for the final answer of 1/5 pi. So, taking that center angle now of pi over 5 in radian, multiplying it by the radius, we get 790 pi. To get a nice approximate answer, the rounded decimal of 3.14 can be plugged in for pi, and after making that substitution and multiplying 3.14 times 790, rounding to the nearest whole number, we find that the distance from VGCC to the North Pole is 2,481 miles. Our next example just reminds us that a formula can be used to find the value of any missing piece as long as there's only one unknown. So of course, usually the unknown in the formula we're currently working with is S, the arc length. But if the arc length is known and you need to find the measure of R or theta, again, as long as there's only one unknown, we can solve and find it. So this problem reads, a 150-degree central angle intercepts an arc of 26 2/10 inches. Calculate the radius of the circle. So we know the arc length. It was given. We can go ahead and substitute it in. 26 2/10 for the arc length for S. We're asked to find the radius, so obviously we do not know it. We copy the equal sign. We keep R for the radius since it's unknown. Of course, we have to plug in our angle measurement. You must remember every time you use the arc length formula, the angle must be in radian. It was given to us as 150 degrees. So as before, we need to convert that degree amount to radian by multiplying by the fraction pi over 180 degrees, allowing those degrees once again to cross cancel out, leaving us with 150 pi over 180, which simplifies, reduces to 5 pi over 6. So now I'm plugging in that angle measurement in radian, 5 pi over 6. The only thing left is just to solve for r. We know we isolate our variable by doing the opposite operation. R is being multiplied by 5 power over 6. Opposite of multiplying is dividing. Since we are dividing by fraction, we have to use those arithmetic rules for dividing by fractions, by a fraction, which is to flip the fraction to invert and multiply. Plus over here, everything cross cancels, leaving r nicely by itself. And on the right hand side, 6 times 26 and 2/10. That answer is divided by 5 pi. Since 5 pi times the understood 1 just leaves us with a denominator of 5 pi. Once again, I plugged in 3.14 for pi. Given a final answer, that's it. That is approximate since the decimal amount that was rounded was plugged in. Final answer of 10 and 1/100 inch for the radius. There are two types of velocity we will be looking or studying. The first is angular velocity. The angular velocity whose symbol is the letter omega in the Greek alphabet of an object moving along a circular path is the amount of rotation in radians of the object per unit of time, and is therefore calculated by the formula the angular velocity omega equals the central angle theta divided by the time. Yes, of course, when we're traveling along an arc, we have angular velocity. We're traveling on a curve. But just as when we drive down the highway, we can still calculate linear velocity, like when you go around a curve. So the linear velocity, whose symbol is v, of an object moving along a circular path is the distance traveled by the object. That distance is represented by s per unit of time. T represents time and is given by the formula v, the linear velocity, is equal to s, that distance, divided by the time. Just as in our problem with the concerning or involving the distance from Van Scramble to the North Pole, S represents that distance, but S is also the arc length. Therefore, when using this formula, you normally will have to go out to the side and calculate the arc length. Again, remember the formula for S for the arc length, which is also the distance, is equal to R times theta, where theta is required to be in radian units. Examples of calculating angular velocity and linear velocity are in the next video.